So, good morning, everyone. How are you doing today? Excellent. Now, let's try that one more time. Good morning, everyone. How are you doing today? Great, right. That's what I wanted to hear. So, third day of the conference, right? You've heard everything about software, about data, about A/B testing, about AI, and all those other cool things. And you feel pretty smug, right? Because you're much smarter than your colleagues that are not at this conference, correct? Right? Yeah, so if that is the case, why aren't you yet a data-driven AI company? What's going on? You have all the ideas, you have all the knowledge. Why is your company not a data-driven AI company yet? What have you done, or what have you not done, that has caused a situation that your company isn't that yet? Is that a fair question? Yeah, because it's all nice to come to these conferences and stuff, and it's good to learn a bunch of stuff, but if you don't go back home to your company and actually do things with it, it's completely useless, right? We have to take these ideas and actually do something with them and make them real within the organization that I'm working. And it's very easy to say, no, this is the job of the CEO of the company, or the job of the CTO of the company, or of the CIO of the company, but we all know that that's not true. It's the people in this room that make the real business strategy for the company. Because the technology decisions that you take make certain business strategies feasible for the company and other business strategies completely unfeasible for the company. So what we're going to be doing in the coming 50 minutes is I'm going to talk you through what are the 5 steps that you have to go through in order to go from a traditional company, maybe mechanics-driven or purely traditional software-driven, to becoming a full-fledged data-driven AI company. Pretty cool, right? Okay, at least one person is clapping. The rest, I have now insulted to the extent that you're not going to be talking to me anymore. I understand. I have to start by setting a little bit of context. And the first is, this is what we see happen. Many companies started off as either mechanics companies, as electronics companies, or as pure software companies. But the interesting thing is that over time, whether you started off as a mechanics company or you started off as a software company, there is always a next technology that is being added to the equation. Yeah, even if you started off at software, I talked to one of the game companies in Gothenburg recently, and one of the developers there said, you know, Jan, our software is now complete commodity. We don't care about the software really anymore. It's only about the data and the artificial intelligence these days. That's what we care about. But if I talk about digitalization, I will talk a lot about during the day, then what I'm talking about is about the 3 basic technologies that make up digitalization, which are software, data, and artificial intelligence. And the interesting thing that we see is if you look at this, if you started off as a mechanics company, for many companies, mechanics and electronics and even software are now completely commodity. So what we see is that we have to constantly deal with the commodity stuff. We need it in order for our products to work, even if it's just software, but we have to invest in the data and AI in order to make sure that we can capitalize on the next wave of technology and the next wave of technology. And that's where we have to be very good. Because if we're not good at that, you know what happens? We get disrupted. You know what disruption looks like? I worked for Nokia mobile phones at some point. You remember Nokia mobile phones? That's what disruption looks like. You're basically wiped off the face of the planet by an onslaught by US innovative companies and Asian innovative companies, and they basically disrupt you. How does that disruption actually happen in practice most of the time? Well, you know, the interesting thing is that many companies start off well. They start off by focusing on a specific customer need. And when the customer says that they want a certain product, then the company starts with building products that are very much focused on that customer need. And then what happens is that over time, the company becomes more and more focused on the product capability. And this is what you, for instance, see in the automotive industry. I don't want to own a car. I own a car because I have a mobility need. And what the car companies have done over time is they've built nicer and nicer cars. And what it resulted in is very nice cars that are very fuel efficient, very quiet, very fast, and have beautiful infotainment systems. Yeah, but now something happened. Mobile phones GPS technology and mobile apps such as Lyft and Uber came along. And what happened is that I realized that if I live in a big city, for me it's much better to not own a car, but instead have that as a service available for me. So what I see is that my real customer need, which is the mobility, is now being disrupted or replaced with a new customer need. I don't want a car. I want to have mobility as a service. That's the thing that I now want. And if we translate that to digitalization, and what does this mean? It means I don't want to buy and own a product. I want to have access to my product as a service. I don't want to offer a physical offering, here's the CD, or here's the box that the product comes into, but rather I want to have a digital offering. A good example of this is Siemens Healthineers. According to some of my friends at Siemens Healthineers, they now put low-end X-ray machines in doctors and dentist offices in India for free. Yeah, the doctor or the dentist gets the X-ray machine for free and only pays every time he or she takes a picture or takes an X-ray with that system. So I have a pure digital offering. And the final thing that we see as a consequence of digitalization is that we move from a one-dimensional business model, I sell to my customer gives me money, to a multi-dimensional business model. What is happening is that I sell to one customer base, I get data back from that customer base, I process and do analytics on that data, I either anonymize it or aggregate it or I do other things with it, and then I resell that data to a second customer base. And if I do that well, I can use the money that I make with my second customer base to subsidize my first customer base so that I can increase market share in my first customer base, which then makes my data more valuable, which then leads to a situation that I actually get a virtuous cycle where my market share on both sides is constantly increasing. That's what's happening with digitalization. I often get the question, what makes a company digital? Well, if we use email, are we then a digital company? Maybe not. What if we have a website? Or if we use social media? Or if we do video conferencing? Still a notoriously difficult problem at many tech companies. Or no, if we have chatbots. If we have chatbots, we're a digital company, right? Not really. You can all see this happen. We believe, based on our research and the consulting that I do with a bunch of different companies, that there are 8 characteristics of what make a company digital. The first is data-driven decision-making. Every decision that is taken in the organization is based on data. The second is, because I need the data, I need relentless experimentation, such as A/B testing. If I don't know if alternative A or alternative B is better, I have to try out A in the field and I have to try out B in the field, measure which of these two is doing better, and then decide. The third is I want short feedback cycles. Rather than taking a decision now and getting feedback 6, 12, or 18 or 24 months from now, I need feedback within hours, days, or a few weeks. And that's what you see in digital companies. Fourth, decision-making is pushed down in the organization. If I believe that decisions should be based on data, then the decision power should be placed as close as possible to the team that collects the data. So rather than being in a traditional hierarchical hippo situation, where for every decision you have to go up the Christmas tree until you find a hippo that is big enough to make the decision, basically, you give decision power to the people that are close to the data. You all know what HIPPO stands for, right? Highest paid person's opinion. That's what we're talking about here. Yeah? Strategic data collection. If I know that I need to make certain decisions 6, 12 months from now, I already today start to collect data around this topic so that I have something for decision making. A unified data warehouse, pervasive use of AI and automation, and finally new job descriptions. This is the final slide. The slides will be made available, but if you want to take pictures, I look great today, so go ahead. Yeah, so this is what makes the company digital. So what I want to do in the remainder of the talk, the coming 40 minutes, is 3 things. 1, what you have to remember is that digitalization is disrupting industry and society to an extent that we have only seen the early beginnings of. If you think that we've come a long way with all this software and data and AI stuff, we have barely started to scratch the surface. It's important to realize that. Second, digital companies need to be world-class in 3 things. The first is software, and then specifically continuous deployment in DevOps. You have to continuously deliver value to your customers. That's one. Two, data, because data gives you, increases the quality of your decision making. If you make decisions based on data instead of based on opinions, you're always doing better, no matter what comes. That much of the success of the high-tech companies comes from the fact that they always base their decision on data rather than on opinions. The third point is artificial intelligence. I'm going to come back to that in the second half of the talk, but artificial intelligence really allows you to produce superior solutions to almost everything. I work with several AI companies, and I'm blown away with the capability of that technology. And then the final point, which refers to the point that I was trying to make in the beginning, if you want to go this journey, you can't go and sit in the corner and bitch about your management. What you have to do is you have to engage in a systematic transformation process in order to bring the change about, and that's what this talk is about. So what we're going to do is, as quickly as possible, I'm going to tell you a few things about myself and where I come from, so you have an idea what my context is. Then I will talk about trends in industry, and then I will talk about the 5 elements of moving towards a data-driven AI company, and then we'll move to conclusions. I will try to do the first part as quickly as possible. First, I used to be, many years ago, a young and innocent professor of software engineering. In the early 2000s, I got a call from a headhunter who was hiring someone for Nokia. And before I knew it, I was running the Software and Application Technologies Lab at Nokia Research Center. I know that Nokia had a big site here in Copenhagen as well, so some of you may have worked at the same company. Then a few years later, I went to Silicon Valley, and I worked for a company called Intuit. If you're not from the US, you don't know Intuit, but we had more than 50 million customers and 8,000 employees and roughly $4.5 billion in revenue. When I left, I was a vice president there as well. And then a few years ago, I came back to Sweden and returned to my professorship. In addition to that, I run a small consultancy, as you can see, but I'm also involved in a number of startups. And if you're interested in, I work as an angel investor, advisor, and board member for startups. So if that is interesting for you, come and talk to me afterwards. But my day job these days is that I'm an old, grumpy, and cynical professor of software engineering, and I run something called Software Center. Software Center is a collaboration between 14 companies, including Grundfos, one of our proud Danish companies, where we focus on significantly improving the digitalization capability of the European software-intensive systems industry. And we have companies like Siemens and Ericsson and Wärtsilä and Scania and Jeppesen and Tetra Pak and Saab Defense, not the bankrupt Dutch car company, by the way. I'm not sure who of you know the story that Saab Automobile was then bought by Spyker, one of the Dutch car companies, and then some Russian mafia got involved and it became really ugly. Volvo Cars, Volvo Trucks, China, Europe Vehicle Technologies, Access Communications, and Lund, some of you may know them. Bosch, not related to me from a family perspective, unfortunately. And then, of course, Grundfos. And we have a number of universities. We look into things like continuous integration, continuous deployment, and DevOps, testing, and those kind of things. We look into continuous architecture, technical debt management. We look into metrics. We look into customer data and ecosystems. And the newest theme that we've started to build up is what we call AI engineering, because everyone in AI is talking about the algorithms and the training and the evaluation. And you know what? All that stuff you get for free these days. The hard part is getting high-quality data sets and high-quality data streams in place and deploying AI solutions in industry-strength production quality deployments. That's the hard part, and we call it AI engineering, and we'll talk more about later on. Yeah, we have all kinds of cool stuff around systems engineering and general management and product management and functional safety, but I'm not going to talk about that. What I do want to mention is that we do not only work with companies that were born with a metal bar in their hands, but basically we also talk to companies like Booking, Spotify, Rovio. You remember Angry Birds? Did you know that Angry Birds is 10 years old now? Does it make you feel younger or older? You decide, all right? Klarna, King. You know King? Company behind Candy Crush? Who plays Candy Crush? Okay, you know, this is the first audience where one person, the gentleman in the blue shirt in the back, is admitting to playing Candy Crush. This is really interesting. More than 300 million people play Candy Crush. And in the thousands of people that I've given presentations for, no one has admitted to playing Candy Crush except for you. So you're my hero today. Well done. Yeah? That was for him. Well done. You got an applause. Yeah, you didn't even expect it. And then finally, Microsoft, some of our former PhD students, some from Malmö University, are now at Microsoft in the data science team in Seattle. So that's who I am. Oh, and finally, Peltarion. If you like deep learning and you want to learn more about platforms, go to peltarion.com. I'm on the board of the company. Awesome company. Best deep learning platform in the industry, and I'm biased. Just saying. Trends in industry. Yeah. So if you look at the Gartner technology hype cycle, I need to speed up a little bit because I spent too much time in the first slides. If you look at every topic on that list, almost every topic of that list is driven by a digital technology, typically at least software and often also data and artificial intelligence. And we can see this because if you look at what is happening in the industry, depending on the industry that you're in, the size of the software in your systems goes up with an order of magnitude every 5 to 10 years. And you all remember your math, right? This is a logarithmic scale, just for the record, yeah? So if you go one step up, it is basically 10 times as large. Yeah, and you know, the thing is that if you're building a system with 1 million lines of code, the architectures, ways of working, and tooling that you figured out for that, they don't work when you're building a 10 million line of code system. And if you finally figured out how to do that from an architecture, tooling, and process and ways of working perspective, then you don't have a solution for building 100 million lines of code systems. And who is building 100 million lines of code systems these days? Well, the automotive industry. If you look at Volvo Cars, a modern car, according to my friends at Volvo Cars, has well over 100 million lines of code in that car. It's one of the most complex products out there. It's right on there in terms of software size together with an Airbus 380. Yeah, so it's really, really complicated. If we look at data, it's very hard to find numbers in the world. Yeah, one reference that I found said that 50 terabytes of data is created every second. I think this is a gross underestimation. So maybe we should use some examples. Yeah, so over the last minute, almost 700,000 hours of Netflix video were watched, 4.5 million YouTube videos. Where is it? Google, 4.5 million Google searches. For those of you, anyone here using Tinder? Interesting. Even fewer people will admit to using Tinder than those that that play Candy Crush. But for those of you that I've been married for a long time, I don't know how it works, but the way my friends explained it to me is that you swipe left or right. Over the last minute, 1.4 million swipes. Yeah, that's what we're talking about. And this, my friends, is just data generated by human beings. Now we're moving to a world with 50 billion connected devices. The amount of data generated by devices will vastly outweigh any data that we can generate as human beings. Yeah, and that brings me to the next field, AI. Just to be clear, we talk about AI. Within AI, we have machine learning from the spam filters, you know those. And within machine learning, we have a subfield called deep learning. Why is this happening right now? After the long, long AI winter, why do we finally see some progress on AI? Well, because of the big data era, there is now vastly more data available, and you need lots and lots of data for the current generation of algorithms. We have, especially with GPUs, computing power up to the wazoo, much more than we even had 5 or 10 years ago. There have been some algorithmic improvements, and there is some better tooling. But by and large, it is the upper two. I think you all know how deep learning works. You have a new multi-layered neural network, you train, and then you deploy, and then that is used to basically give the right answer. If someone like Sergey Brin says that the new spring in AI is the most significant development in computing in my lifetime, then I think you can safely say that we're onto something. Final trend before we go into the content of the 5 steps, need for speed. What many people do not realize, and the last talk I thought brought this up really, really nicely, is that the customer adoption of new technologies, new applications, new offerings, new products, new solutions has never been faster. Here you see 4 products, Quicken, eBay, Facebook, and Angry Birds. And you can see how long it took each of those products to get to 1 million to 50 million users. The adoption rate in society for new technologies has never been faster. And today is the slowest day of technology adoption ever. Yeah, it will only accelerate. We see this in every trend that we find. We see that the technology adoption is going faster. And I know that everyone is getting a little worried about speed because I have to work so hard and what happened to my 36-hour work week and my 7 weeks of vacation. But I just want to talk you through the economics of why speed matters. Yeah, here's an example. I have a company. The company sells a product at $1 billion a year. Yeah, not untypical for some of the Danish companies. Most companies express their R&D budget, so how much R&D budget do we have, as a percentage of revenue. So I put it at 10%. That gives me $100 million R&D budget. Do I have to explain the math, or does it work? You know, I live in Sweden these days, and in Sweden we have some issues with our math education, so I sometimes have to explain it, but let's not go there. This was a joke for all the Danes in the room. And the Swedes can laugh in a kind of self-deprecating kind of way. Yeah? New product development cycle is 12 months. Now I'm going to give you 2 alternatives. The first alternative is I am going to focus everything I can on efficiency. And lo and behold, I'm successful. I'm 10% more efficient. And I'm saving $10 million in R&D costs. So instead of spending $100 million, I only spent $90 million. That's pretty cool, right? Even after taxes in this country. Yeah, that's still a nice chunk of change. Yeah, not bad. But here's your second alternative. Your second alternative is, I don't focus on efficiency, I focus on speed. And I try to get a product out as rapidly as possible. And I'm successful. I'm 10% faster than what I would have been otherwise. Yeah, so I still spent the $100 million, but I'm 10% faster. And if I'm selling at a flat rate of $1 billion a year, and I'm not cannibalizing any existing products, then just by being 10% faster and being able to start to sell my product 1.2 months earlier, I am adding $100 million of additional top-line revenue to the company. What would you rather have, 10 million of savings or $100 million of additional top-line revenue? Top line. You know, in most audiences, I always have a smart ass in the audience that says, I want both. But that was not what I was offering here. Yeah? Do you see the economics? There is nothing that you can do from an efficiency perspective that will outperform cycle time reduction. You've earned back your entire R&D budget just by being faster. Why do you think we care so much about speed? Why do we care about agile? Because of this. This is what drives these kind of things. Okay, how do you become a data-driven AI company? I'm going to go very, very quickly because I have less than half an hour left to 5 aspects: fast feedback loops, data-driven development, value modeling, differentiating functionality, and AI-driven development. The first, you are all on a journey. Some of you are further along, some of you are not as far along, and the journey is very predictable, and you all go through the same pattern. We've worked with dozens of companies, and it looks always the same. You start by going agile. You've all done that. The next step is that you go and you do continuous integration. And when you do continuous integration, you are always at production quality. Whenever you check in code, any developer checks in code within minutes, hours, or a day or two, you know that the code you built is still at production quality. Once you reach that stage, you can move towards continuous deployment or DevOps. That's when your code can go out at least once every agile sprint. You go out live with your software. Once you can do continuous deployment, you can move to what we call R&D as an innovation system, which is when I can start to push out version A for some customers and version B for some customers, measure how they're using it, and then based on that, decide whether I'm going to give everyone version A of this feature or function, or I'm going to give everyone version B of this feature or function, because I have tested it in the field. This allows me to actually move fast. Why do I care so much about speed? Because development cycle, requirement cycle, quality assurance, governance cycle, deployment cycle, and value creation cycle. There are 6 cycles in development. And with every step that I go up, one of these cycles go from long to sprint-based. And why do I care about this? If I have a long feedback cycle, I will be bound to take an opinion-based decision. If I have to choose, are we going to do A or are we going to do B? And I have to wait 6 or 12 months before I get feedback on my decision, I'm just going to do my best guess. I'm just going to take either A or B and move on with my life. If, however, within 2 or 3 weeks I can get feedback on choice A and choice B, I may be willing to take a step back and say, okay, let's try out A and measure how A does. Let's try out B and measure how B does, and then decide based on the data. That makes life a heck of a lot easier. Second, this was pretty quick, right? So good so far? Are you with me or are you against me? With me, good. You know, people with my last name, Bosch. Yeah, this is a Trump joke, by the way, just for the record. Yeah, so people with my last name, when they moved to the US, they changed their name into Bush. Yeah, and I used to be really troubled by that. But these days I think, well, at least it isn't Trump. Okay, sorry. I'm not sure if that resonates with you, but I apologize for all the Americans in the room. I do think Trump is doing a few great things like take on China, as we saw in the previous talk, right? Okay, here's the interesting thing. All of you building code, building new features, know this. Somewhere between 50 and 65% of all the features and all the functionality that you have built throughout your entire life has been a bloody waste. It's never used, or it is used so seldomly that your time investment into that feature functionality wasn't worth it. This is a very old study by Standish Group, which basically says that rarely used 64%. We did our own study with a company in Sweden, in Gothenburg. After they saw the data, they wanted to stay anonymous. I don't know why. And what you see is some features I used a lot, some features I used occasionally, many features I never used. Yeah, so when I go into my consulting gigs with companies, my sales pitch is, half of all your R&D is waste. You just don't know which half. I can help. Pretty good, right? You have to give me that. That's a good sales pitch. Yeah. So we've done a couple of things in this area. The first is we developed a HYPEX model. Yeah, the HYPEX model is basically, I have a strategic product goal, I have a feature backlog, I pick my highest priority feature, but before I start any development, I sit down with product management and all the other stakeholders and I say, if we build this feature, what are the measurable differences in the product behavior or in the customer behavior that justify us building this feature? How can I measure that this feature is valuable? And I can talk about a lot of things about different types of features. These are features that are intended to be used by customers. If I built this feature, what will we measure in terms of expected behavior that justifies us investing in that feature? And then what you do is you build the minimal viable feature, or in the startup terminology is now the MLF, the minimal lovable feature. Right? You've all heard that one, right? So I build the first 10, 15% of the feature, and I deploy it. That's why I need to have continuous deployment. And I instrument it, and then I can get actual behavior. And now the actual interesting thing happens. You may well end up in a situation that you've built 20% of the feature and you see nothing of what you expected is actually happening. Then you should just ditch the feature. Yeah, or you built 30% of the feature, you got everything you wanted. Why build the rest? Why bother with the other 70%? Just move on to the next feature. Sometimes you see some movement, but not enough, and then you keep iteratively investing until the return actually starts to plateau. And sometimes you get the really funky data back from the field, and you realize customers want something like this, but not in the way that we built this, so we have to build it in a different way. So that's the HYPEX model. The other way, I don't know how many talks there were on A/B testing here, but in our work with Microsoft, this is one of the examples that we use a lot. This is in the Bing search engine, which is actually used a lot, not in Europe, but elsewhere, because it's also white label sold to a few other players. But here's the thing, you have ads on the side, and here I have an experiment. Yeah, the experiment is to figure out the impact of showing the discount in a weekly deal stripe, and the weekly deal stripe sits on the side of the Bing search engine, or at the bottom, I forgot. Yeah, and the value hypothesis is that I'm looking for the alternative that increases engagement with the stripe and thus leads to no decrease in purchases. And now I have three alternatives. A, this is the control. This was how it was initially done. This is B, when I show the prices, but I still manually order the games that are shown to the user. And C, where I show the prices, but I also automatically pick which games to show to which user. Now, which of these A/B experiments, which of these alternatives is the best? Who thinks A is the best? No one. You're a careful bunch. Who thinks B is best? There's a few people. Who thinks C is best? Very good. So out treatment B decreased engagement with the Stripe, but purchases stayed the same. Treatment C increased both engagement with the Stripe and the purchases made. This is a very simple A/B experiment. But the point is, the big digital companies in the world, they don't run one A/B experiment. They run thousands of A/B experiments in parallel. Yeah, one of the companies that I work with, the former CTO, told me that they ran more than 30,000 A/B experiments during 2016. Yeah, and how do you do that? Well, then you build a fabulous infrastructure that looks like this. Now you have to really build very elaborate infrastructures to make sure that different experiments do not overlap with each other. This is one of our PhD students and his research, in case you're interested. But you don't only do this in the B2C online world. You can also do this in the embedded systems world. And maybe this model is a little bit easier, but this is one of the companies in Software Center, a big, think 100,000 person plus, B2B company that is now doing DevOps, yeah? So they get stuff out every 2 weeks to their customers, and they have a complete experimentation chain where they start with internal experimentation and validation, then they move to single customer verification, and then they move to multiple customer deployment verification, and they run all kinds of A/B experiments, quasi-experiments, dark launches, crossover experiments, and other types of experimentation in the system. You can experiment in your systems too, and you should do so. Yeah, we have looked at how do companies evolve. You go from working with data in an ad hoc fashion to automated collection, to automation, to data innovation, to evidence-based organization. I have a great story here, but in the interest of time, I will not spend too much time on this. Value modeling. Are you ready for a reality check? Yeah, good. Value creation in R&D. I think that this is an important thing to talk about. How much value are you creating for the company that you work for? How much value should you create for the company that you're working for? Here is an example. I have a company. This company is a big B2B company, so their R&D budget is 5% of revenue. You still with me? Yeah, it works, huh? I have an agile team of 8 people. Quite reasonable, right? I have a sprint length, of 3 weeks. What does the agile team cost every 3 weeks? It's quite easy, right? 24-person weeks, which is roughly half of a full-time equivalent, or a full-time person for a year. A full-time person in a year in Western Europe typically costs somewhere between around 120,000 euros if you count all the taxes and the overhead and the meat and the desk and the computer and all the other things that come with having an employee. So that means that every agile team, every agile sprint costs 60,000 euros. Is there anything wrong in my math? You don't like this. I don't know why, but everyone's looking really angry at me. Does this make sense or not? Yes, right? This is your cost. How much value should you create in this company in order to justify your existence within the organization? You want to know the answer? 5% of R&D means that every euro that goes into R&D has to generate 20 euros of business value. There's nothing magical about it. This is just how it works. Yeah? Which means that every agile team, every agile sprint has to generate 20 times their cost of 60,000 euros. Which means that every agile team, every agile sprint in your company has to generate 1.2 million euros, or what is it, 10 million Danish? What is it, 10 million Danish? Is that roughly a reasonable calculation? Every agile team here in Denmark, assuming you're at 5% of revenue, has to generate 10 million Danish kroners of business value for the company that you're working. Yes? Do you feel better or worse now? Worse, he says. This is the reality of economics in R&D. It's very simple. You choose what your R&D percentage is, and based on what your R&D percentage is, divided by 100%, or 100% divided by your R&D percentage, gives you a multiplier, and that multiplier is what every dollar or euro or Danish krona or Swedish krona or whatever it is invested in R&D has to generate that multiplier in business value. Now think for yourself, am I spending my time, when you're not at GOTO Copenhagen, of course, am I spending my time really in such a way that I can guarantee that every agile sprint I'm generating this much business value? And I can promise you that you're not thinking so hard about this. But digital companies think really hard about this. This is from one of the companies that we work with, online company, lots and lots of customers. They have a fully developed hierarchical value model where they go from top-level factors like revenue, number of customers, monthly active users, etc., to subsystem-level metrics, to team-level or feature-level metrics. And they basically have a team, basically an agile team that does nothing else but basically measure and establish the relationships between fast-moving, low-level, feature-level, and team-level metrics and high-level business-level metrics. Yeah, at the top level, you may, for instance, have Net Promoter Score. How likely are you to recommend this product to your best friend? Yeah, that's one of the Net Promoter Scores that you may have heard of. That one moves really, really slow. But there are things like DAO and MAU, daily active users and monthly active users, that move much more slow, that move much more fast. And then you need to know what is the relationship between those two. We have a beautiful theoretical model that I'm happy to talk with you about, but I'm not going to do that. What I'm going to show you is a few examples of how do you actually work with this in practice. If we work with this in practice, well, the first is what we do with companies. We look at a complete list of what are features that people would like to do value modeling on. And then we pick a feature. For instance, in this case, this is from a company that does flight and crew planning for airlines. And what every pilot or cabin crew member has is they get their 30-day schedule in a mobile app. And then if they say that they get to fly to Shanghai or whatever it is again, and they don't want to fly to Shanghai because they don't like the city or whatever it is, they can request to drop a trip. Can you see that? So then they basically, that trip gets, the airline tries to remove that trip from their flight schedule, and then maybe they get another trip. They get to fly to New York or whatever it is. Yeah? So that's the feature that they selected. Then the next thing that you go, and I'm going to click one more time because then you can see it more easily. You go, and what are the measurable factors that I care about? Feedback time, success rate, number of users, a successful number of drops, the cost for the company, etc. Once I've picked the factors, I basically say, I decide what is the right direction for these factors. Yeah? And maybe it's going up, maybe it's going down. And then I say, okay, what is the relative priority? Well, feedback time should be 10% of the overall score. The second one, success rate, should be 20%, etc. So you basically divide 100% over the factors that you've picked. And what you can then do is you can basically come up with a value function. You measure what the current baseline is, and then you start to iterate in order to improve the value that this particular feature or function is providing to the system. And that you can provide in all kinds of other ways. I mean, this is adaptive cruise control in a Swedish car company that shall remain unnamed. Okay, no. Not sure if that helped, but in any case, yeah. So what we then did, we identified the key values, the key value factors, we set the direction of values, we prioritized the key values, and then we come up with a value function. In a German company that builds components for electric bikes. What am I doing so far? Not sure how many of those you know. There are actually more than one out there. I mean, we also created value models like around customer preferences, around revenue, about the users, around feature usage, etc. And then what we did was, okay, if we want to influence these things, we formulate a hypothesis, we identify what data points we need in order to test that hypothesis, and then we collect actions with the team. What do we need to do in order to actually create those or to measure those factors? So we have hypotheses and actions, hypotheses and actions. Another example here is in the flight and crew planning again. You know, this is what a planner in an airline sees. You know, I have selected a certain flight, but then seeing where all the affected flight schedules are is actually really hard. Sorry, this is not a flight. I think this may be, yeah, this is a flight number. So the problem is difficult to see. So the team, the development team, came up with a hypothesis, which says, we think the time to locate filtered objects would decrease if objects that match a filtering criteria were highlighted. So what they did was they basically added a feature. Do you see the yellow stuff over there? When I select the flight, I now can see which of these things are highlighted when I turn on the highlighting feature, which you can also turn off, by the way. And then they measured, and they proved that customers were actually liking this, and they were faster when they're doing this. The second hypothesis that they worked with is that we believe that the time to perform a task will decrease if the user gets support to select the highlighted objects with a quick command. So they introduced the Ctrl-H, and then you would select, and then you could actually measure this. And what they did was they did not only measure how customers behaved, they also ran a survey where they measured how customers actually thought of this thing. So we combine qualitative and quantitative data. And in this way, you can actually work with value modeling to measure whether the feature that you're building is actually generating the intended impact. Even if you don't go all the way to dollars and euros and Danish kroners, you can at least show in terms of customer engagement and system behavior that this works. Are you with me so far? Makes sense? 11 minutes. Can you manage so long? Yeah, hang in there. This is cool. Now we're getting closer and closer to AI, which is I know you're all waiting for. Yeah, so a very simple model. I'm not a very smart person. When I walked into this room, the average IQ dropped remarkably. So I only can do simple models. This is a very simple model. The 3-layer product model, the reference is in the bottom. What I've basically said is every product, every platform, every product portfolio has 3 layers of functionality. There's a layer of commodity functionality, stuff that you need for your product to work, but no one gives a flying hoot about the functionality. Remember, when you picked your new mobile phone, the fact that you could make calls with that mobile phone did not factor into your buying decision because it's a commodity feature. You would have been really pissed off, sorry, polite audience. You would have been really annoyed if you couldn't make calls with your mobile phone. Yeah, but I mean, in principle, you're assuming it's there. It's a commodity feature. On top of that sits a differentiating functionality layer. That's where all the features live that are really valuable, that customers want to, that customers pick you over competitors for. And if you now look at the mobile phone space, you see those phones with 5 cameras in the back. You may have seen that. So you can take 3D images and all of this great stuff. That's now differentiating. Yeah, and then on top of that sits a layer of innovative and experimental functionality. And what happens is that something starts off as innovative and experimental, and 1 out of 10 things is really successful. It gets productized because customers love it. It sits in your differentiating functionality layer for a while, a few weeks, a few months, a few years, depending on the industry that you're in. And then what happens is that it starts to commoditize and it flows into the commodity layer. With me so far? I've now asked well over 50 companies, what percentage of your R&D goes into commodity functionality, stuff that no customer cares about as long as it works, and what percentage of your R&D goes into differentiating, innovative, and experimental functionality? You want to know the answer? Our data shows that on average, across the industry, companies spend 80 to 90% of their R&D efforts on commodity functionality. Stuff that no customer gives a flying hoot about. No one cares as long as it works. So look in the row that you're sitting. In the row that you're sitting, you are the only one that is working on differentiating functionality. Everyone else is working on commodity. Yeah, and I don't have time to go through the details of what to do about it. We've developed something called the 3-layer ecosystem strategy model. So we have a whole bunch of strategies that you can apply to free up your resources from the commodity layer and make them available up there. If you want to know more, come and talk to me afterwards. But remember this, the state of software engineering these days is 8 or 9 out of every 10 work on stuff that no customer cares about. And the 1 or 2 that work on new stuff get it wrong half the time. Yeah, that's the state of software development today, and I believe we can do much better by becoming much more data-driven. Now we go to the AI part. Yeah? We believe that the future of software development consists of bringing 3 different types of development together in one system. Sorry, it's a bit dry here. Yeah, so the first is we will still have traditional requirements-driven engineering. We have this for regulatory features, we have this for competitive parity features, we have this for commodity features. Next to that, we have what we call outcome or data-driven development. Then a team doesn't get a requirement. What they get is conversion on your part of the website is currently 3.2%, which means that 32 people out of every 1,000 do what you wanted to do. Your goal for the coming quarter is to move it from 3.2 to 3.4%. And I don't care how you do it. If you want to go and meditate on the meaning of life, you do that. If you want to go and do ethnographic studies with users, you do that. If you want to go pogo sticking in the center of Copenhagen, you do that. If you want to do a fundamental redesign and make it faster, you do that. But get me the outcome. That's what I care about. And there are teams like this. If you go to Booking.com, a team at Booking.com will never see a requirement in their life. It's a bit of an exaggeration, but by and large, it's all data-driven and A/B testing centers. The third part is AI-driven development. I have a large data set. I have a machine learning or deep learning model. I train it, I minimize prediction errors, and I get the model out. And what happens is that systems in the future, sorry, this is a bit hard to see, will have components developed this way, and this way. They will all generate behavioral data, so I know how each component and the system as a whole is behaving. And they are all subject to DevOps or continuous deployment. And this is important to realize. Also, AI components, at least based on our research with the companies that we believe are the most advanced, get constantly updated, changed, experimented with, etc. Yeah, so every 2 weeks, if you go to a company like Microsoft, they will actually have a new version of the algorithm or of the model that is doing slightly better in training than what you would see otherwise. And then they deploy the new model next to the old model in a kind of A/B testing environment. They shuffle a little bit of traffic to the new model in order to compare how it performs. And if it performs better in operations as well as in training, then that model gets deployed. Yeah, so all these components, also AI components, will be subject to DevOps. Now, here's the problem about AI, because we are in the hype cycle, on the top of the hype cycle for AI. This is Jonas, yeah, a decent Swedish guy. Jonas has a problem. Jonas has an idea. I'm going to use AI to solve the problem. Everyone does it, so why not me, right? So Jonas gets a big data chunk together. He gets a neural network together, a nice deep learning multi-layered neural network. He goes and trains the little brain. Isn't that a cute picture, right? And then success. This model performs fantastic on the data sets that we gave it. Yeah, does beautifully. And here's what everyone says. Jonas, this is great. Let's go live with this. We're going to deploy this everywhere. We're going to be rich. We're going to be famous. We're going to be happy. We're going to live happily ever after. And you know what happens? It fails. It very often fails. I've seen dozens of cases that look like this. Why does this happen? Well, the interesting thing is, as long as you're in the experimentation and prototyping phase, you don't need any engineering. You can just play around. But once you get to non-critical deployment of machine learning components, or critical deployment, or cascading deployment when one model feeds into the next model, or even autonomous deployment where models retrain themselves automatically, monitor their own behavior, will trigger or give alarms when they need human intervention, etc. Once you get to the higher stages, you need software engineering for AI, or operational AI, or AI engineering, as we call it. And we're not the first ones to say this. This is a paper by Google. Do you see the little, or authors are working at Google, do you see the little black box in the middle? That's the machine learning code. Do you see all the boxes around it? That's what you need to actually create a production quality industry strength deployment of a machine learning model. You thought you were going to be obsolescent? We don't need software engineers anymore because of AI? Well, you better think again. All this stuff needs to work. Otherwise, that thing is just sitting in a vacuum, not generating any value. Now, we have done lots of, I will show 3 studies very, very quickly. Engineering challenges for deep learning systems. If you want to know more, come and talk to me afterwards. A second study about automotive, web, telecom deployments. Again, we looked at the different stages that you have. Sorry, I clicked to this. I'm almost out of time, so I need to click through this very quickly. We looked at what are the data management challenges that companies are experiencing. But what I want to leave you with is a few thoughts. The first is, in the simplest form, an AI project is get the data together, create the machine learning and deep learning models, train and evaluate and deploy. Everyone talks about the algorithms and everyone talks about trading and evaluation. That's where the attention goes. You know where the effort goes? Exactly the other way around. Getting the darn data together is really, really hard. High quality data sets, high quality data streams. Yeah? Once I deploy, I don't want to rely on a data set. I want to have a live data stream coming into this thing. Setting all of that up and deploying it in a reliable and predictable and monitored environment is actually really difficult. Yeah, and if you look at what is the real process, well, let's start with a business case. How do we actually deploy this in practice? Yeah, and then we go to data exploration, then we go to feature engineering, then we go to experimentation, to development, and then we finally go to deployment. There are multiple steps in there. I have a whole AI overview of all the topics that if you look in the center, this is the traditional AI activities, yeah? Data set, create the model, and then train and evaluate. These are all the things that you need in a generic AI engineering context. If you build a software-intensive embedded system, you have a few other things. Yeah, because suddenly your machine learning model will be deployed in, I don't know, 500,000 base stations. How are you going to deal with that? Or in 400,000 cars. How are you going to deal with that? If you have safety-critical systems, then suddenly explainable models becomes very important because, you know, we all want self-driving cars, but we don't want to die in a self-driving car last time I checked. Yeah? And then finally, if you have autonomously improving systems, we look at, you know, automated experimentation, one of the other topics that we're looking at. Yeah, so AI engineering, there's a lot of really cool stuff happening, but don't underestimate the engineering challenges of putting these things into production, because that's where I see many companies go wrong. Conclusion, with 44 seconds to go. Not bad, eh? You took my 40 seconds in the beginning. Digitalization is disrupting industry and society to an extent that we've only seen the beginnings of. We are just in the early stages of a fabulous journey. You know, I'm jealous of my kids because I think that the amount of change that we're going to see in the coming decades is vastly outpacing whatever we've seen so far. This is just the beginning. Digital companies need three things: software, continuous deployment, to continuously deliver value and to continuously deliver more value. Data, to increase the quality of decision making. I showed you some examples of that. And AI provides superior solutions to almost everything. In order to get from where you are today, however, to delivering on this promise, you need a systematic transformation process. That's why you saw those 5-step stairs all the time, because you can't go and jump there in one go. You actually have to go through a systematic change process. I know you like to read, or not. This book you have to buy on Amazon if you want to know a bit more about what I do. These two books, the middle two, I basically sell on Amazon.com for $9.99 a piece. But because I love you guys so much, if you drop me an email, jan@janbosch.com, I will send these PDFs to you for free. Free as in beer. Yeah? Not bad, huh? This one you'll have to buy from me. I have a box sitting at home and I ship these kind of books off if you're interested. And with that, my friends, thank you very much for your attention. Let's go to questions. Thanks.